Hi, this is Brandon Baines in the Math Department at Lipscomb University, here to talk with you about counting the number of sets of a certain size. In this app, you'll learn how to count the number of sets of a certain size from a collection of objects. For example, if there are 20 boys that try out for the junior high basketball team and only 12 available positions on the team, we want to know how many ways the 12 positions can be filled. This scenario differs from our previous presentation about permutations because the order is not important here. Consider 12 positions that might be representing the boys on this basketball team. Well, if you take those 12 names and write them in one order and then rewrite them in a different order, you still would have the same basketball team. And so in this case, our order of our objects, in this case our basketball players, doesn't matter. So this is something different than a permutation because order does not matter. To calculate the number of sets of a certain size, we use NCR. This is n factorial divided by the product of r factorial and n minus r factorial. So you'll see here that if you compare that back to NPR from our previous presentation, it's very similar. There is just one difference. The difference is that in the divisor, when we look here in the divisor, we are dividing by an additional factor of r factorial. And what that's doing is it's dividing out all of the times when we think order is important and we count those different orderings as different outcomes, that r factorial is actually dividing those out so that we only count those one time. Let's take a look at an example. Lottery problems are very good examples to begin with here. Let's take a look at a lottery game that has players select 5 numbers from 1 through 60. For example, a possible lottery ticket could be 12, 14, 29, 30, and 33. In this counting problem, we want to know how many different lottery tickets are possible. The solution here is to do 60 numbers, choose 5, make sets of 5 numbers. And again, following that definition of 60 or of NCR, using 60 as N and 5 as R, you can see here on the screen that we go through a bit of cleanup here with that formula, and that ends up resulting in 5,461,512 ways. One thing that students often struggle with when we start these counting problems that involve combinations instead of the permutations, they struggle with determining whether they should use NPR or NCR. And so the thing I would always tell students to do is to take an example like the one we had in this problem and write that example down in a different order. Okay, so in this case, maybe write 33 in the front and put the 12 in the back. Is that a different lottery ticket than the one in the example? If the answer is no, and in this case it is no, it's still the same lottery ticket. It still has the same numbers on it. Then that tells us that we're dealing with this NCR kind of counting problem. However, if we were to change that order and we were to say, oh, that's a different outcome, then we would be dealing with an NPR, with one of those permutations. Let's take a look at a second example, still using the lottery. This time, this lottery game has decided to make a Powerball part of its lottery game, and they're going to use the numbers 1 through 20 for their Powerball. So we want to know how many different lottery tickets are possible now. And so what we're going to see as we continue to count is that counting problems will often go back to the fundamental counting principle that we talked about in the first presentation in this app. And so in this case, we have that. We have two events. We have the event of selecting the 5 numbers, and we have the event of choosing our Powerball. Well, in the previous problem, we found how many ways we could choose 5 numbers, 5,461,512. And we know that there are 20 Powerball numbers, 1 through 20, so we're going to select one of those 20 ways to get a Powerball. The fundamental counting principle will put it all together for us. We will multiply the number of ways to select 5 numbers times the number of ways to select our Powerball, and that results in 109,230,240 ways.